Hello, everyone. Hopefully, I'm the last talk before lunch, right? Is that right? I don't know if I am. Okay. So I'll try and make it brief. So that's me, Paul Dongha, head of responsible AI and AI strategy, and I have Sean Roberts from my team, who's our agentic AI expert, who's also in the room as well. So if there's a question I can't answer, you can turn to Sean. AI agents is all the buzzword, right? It seems to be the new buzzword of 2025. So we've kind of gone beyond the Gen AI hype cycle, and I kind of think we've got another one now, and I think it's this kind of thing. So this is not a very complex presentation. The previous one was really quite deep. This is just going to ask probably more basic questions, like kind of what is an agent? Because everyone seems to be talking about them. So I just want to explore that topic for a few minutes and maybe talk about some of the risks. I guess in its most simplest form, to us, agentic AI is really a natural progression of what we've seen from machine learning through generative AI. More recently, we've had the so-called reasoning models. Some people call them thinking. If you're OpenAI, they've been talking to me about their models thinking. I'm not quite sure they do, but that's what they call it. Say reasoning is probably acceptable, I think. From an ethics point of view, I'm not even sure about that. But certainly things like reinforcement learning has given us reason to pause and think, look, if we can look at how the models operate, once you send a prompt and you have a look at the intermediate tokens generated, a chain of thought, and so on and so forth, maybe there's something in there about transparency and explainability. And of course, agentic AI, as I said earlier, is a bit of a fuzzy topic in my mind, actually. We've got the good, the bad, and the ugly. This talk will also talk about the ugly part, which is about the impacts on the environment from agentic AI. And I have a couple of slides on that because it is significantly more compute intensive, some studies are showing, because of intermediate tokens that are generated through the so-called reasoning process. We tried in NatWest to think, well, what are the two major things that set agentic AI apart from LLMs? And we just thought we'd boil down to probably, these major two dimensions of autonomy and on one axis and reasoning and planning on the other axis. So autonomy, we can think of using an LLM and letting it do more stuff without a human in the loop. That kind of feels like an autonomy, or certainly an axis where we could talk about how much freedom we give an LLM. And reasoning and planning really refers to how many activities we might allow the agent to do. So rather than a ChatGPT query being a simple query and an answer, maybe it boils down to setting the agent an objective and saying, go and figure out how to do it. Or planning, which is to plan the sequence of activities to achieve a particular goal or a particular outcome. I talk about reasoning and planning because to me, they're really, really important parts of what makes agentic AI. I was fortunate or unfortunate enough to work on agentic AI in the 90s. It did actually exist, although the technology was far behind what we've got today. And the ability for an AI system to be able to figure out how to achieve a goal was always really one of the panaceas that we were trying to resolve in those days. It's fine if you have a workflow and you set an AI agent and say, follow this sequence of steps to achieve that goal. And you give it that sequence, that workflow, that business process, call it what you will. If you give it the recipe and the steps, by and large, as long as you've got certain significant explainability, you can kind of get to that point. But setting an agent off to do something without telling it how to do it, or the recipe for how to achieve it, certainly does expose us to a lot more risks. So I kind of see this confluence of autonomy coming together with reasoning and planning in the top right-hand corner of this matrix to be something that I would think of as agentic AI. If I just move on. So then we looked at it from a level of risk. So we thought, if on the x-axis we've got autonomy, reasoning, and planning, well, what happens to our level of risks? And because I come from a responsible AI perspective at this, the risk part is quite close to my heart. And of course, risk levels increase the more agentic something becomes. I apologize for the small font. This is not very legible. But as we go around the bank, a lot of business units are saying, oh, can I have an agent? Or I want to do agentic AI because that's going to solve this problem and that problem. So it kind of feels like 2023 and 2024 all over again, but now instead of Gen AI, it's agentic AI. So we thought, look, it's very useful maybe to provide a taxonomy to define the different types of AI agents, so that when we have conversations, when my team have conversations, when my strategy team have conversations around the bank, we can talk to our business stakeholders and say, look, if we have this scale of 1 to 7, where 7 is some kind of panacea, and number 1 is really the most basic kind of rules-based system, where do you think we're talking about your system? From what perspective? And really it boiled down to there are a whole bunch of AI systems that are in the green hoop, and really they have far less autonomy because you have a human in the loop far more, and that's far more where we are right at the moment. Right, so right at the moment, human in the loop is the gold standard for many, many of the Gen AI use cases that we've got around the bank, especially for those use cases that are customer facing and that are part of important business processes, and we have several of those. Agentic AI really, as 5 and 6 point out there, it's not really a human in the loop or a human in control. It's more about the agent doing what it wants to do and maybe checking in with a human operator to say, is this the right next action? Is this the right next step? Or should I do the next step? Using this taxonomy allows us to certainly reason about where we see our risk appetite and where we want to go as an organization in terms of how we talk about agents and where we launch agents. There's also talk of multi-agent systems in the bottom right of the graph, which I just added last night. So multi-agent systems is just a group of agents that talk between themselves to achieve a common goal, which isn't even reflected in the taxonomy really on the left. But I think multi-agent systems certainly seems to be where we're going. But I think agentic AI introduces new risks and amplifies existing risks. There was a very good paper produced earlier this year, it's referenced on the bottom right, that talks about the different types of risks, and it groups them into design risks, reasoning and planning, and autonomy risks, which were the dimensions that we'd come up with towards the end of last year. And without going through each of them in detail, I can maybe pick one out. Under reasoning and planning, cascading hallucination attacks. I mean, it's probably the easiest one to talk about. We all know LLMs have this ability to hallucinate or confabulate, or I just call it an error. I don't really like using that word because it kind of anthropomorphizes what AI is. It's just a mistake. Well, of course, agents interacting or an LLM interacting with another LLM, you can easily see that the multiplicative way one hallucination can lead to many more issues. We have all sorts of examples that are just hitting the press right now of agents spoofing. There's a particular example. I went to a talk where a bank had, in a sandbox, had experimented using reinforcement learning with agents for trading on the markets, options trading. And it actually found that the agents started to do front running. They realized that front running was a very, very good strategy to make more money. For those that aren't familiar with it, front running means you basically pump up the price of an option and then drop it and make a profit on the difference, which is absolutely not, it's illegal, and it's certainly not allowed. Humans have done it. But the interesting thing there was that under an experimental environment, the agent had discovered that this actually was a good strategy. So there's clearly something wrong there with the reward function or the value function in reinforcement learning. But it's a kind of example that shows that actually if you don't put the right guardrails in place, when an agent is executing something it calls a plan, you're likely to have behavior which is kind of unanticipated. So it brings up all sorts of issues around emergent behavior really not aligning well with what we as humans want. So one of the biggest risks, I think, of agentic AI is the alignment problem. And those of you who've read Bostrom's work or Stuart Russell's work, or some of the famous AI researchers will know that the alignment problem is particularly thorny. Getting an agent or an AI system to do what the human designer intended still doesn't have a solution. I think and I believe with agentic AI, actually, it will become even harder to resolve that problem. And then you'll have conversations about runaway AI and singularity and all the rest of it. But I think it's a real threat. I think it's a real issue. I think we need to work on it. I think organizations are sometimes rushing into saying, we're doing agents. Well, if your agent is an instance of Copilot Microsoft 365 on your desktop helping you sort and filter email and maybe summarize a presentation, well, that's fine. You can call that an agent. People do. I don't call those agents. When we use the term agent in the context of some of the work that we're experimenting with, we're talking about a system that does a number of things, solves a sophisticated problem, comes up with a plan for resolving it, possibly communicating with other tools. We're working through this actually. I suppose what I want to say here is, looking at the risks earlier, there are some mitigants that are showing early signs of being, quite useful. Agent identifiers, which is on the top right there. I think actually in future this is going to become really important, whereby how does your AI agent, if it communicates with another tool, and if that tool is an AI agent, which it probably almost certainly will be, how does it know that what it's communicating with is what it thinks it's communicating with? How are agents authenticated? Who has accountability? These, I think, these are really, really important issues that we need to think about now. The other issue, of course, real-time monitoring and activity logs. Multi-agent systems, or agents communicating with tools, the speed with which they can do that. Does human in the loop work? Probably doesn't really work, not in the way that we have human in the loop at the moment. So how do we monitor their behavior? How do we track what they're doing? How do we know whether they're actually getting closer to a solution or further away from a solution? I think there's a lot of work that remains to be done around how we monitor their behavior and control that behavior at the same time. I'm just going to talk a little bit more about energy use, and this talk was intended to be more about AI sustainability, which is something that I also work on, and my team at NatWest work on. This graph here really shows the forecasted demand for energy from Gen AI. It's about a year old. This was before agents, multi-agent systems and all that. That was before DeepSeek or anything like that. And you can see there that the forecast is the energy demand, how it's rocketing. This has been superseded. The US Data Center Energy Report that came out in December 2024, it was kind of similar actually. It was slightly worse. I haven't got that slide in here. But it's still all pointing to the same direction. The energy use, the climate impact, the water usage for cooling data centers is becoming a real nightmare and is forecasted to continue to be. And that's even before agents and agentic AI hit the scene. So I haven't seen a report that tries to forecast agentic AI and its impact on the environment, but it's likely to look something like that, if not even worse. And there's some factoids there on the right, and you can see some of the big tech companies have bought mid-sized nuclear power reactors, although Microsoft have actually reduced their forecasted data center capacity plans by about 14% very recently, maybe something to do with their OpenAI partnership. But the bottom line is, you can see that we do have a problem, and it's only getting worse, and we have issues around misreporting location-based emissions. So, problem we have at the moment. When I talk about sustainable AI, as someone who works in the top half of that circle, responsible AI has really been about managing two things, in my mind, many things, but two major things. It's the accuracy of the model versus its compliance to either policy, ethical principles, or regulatory requirements, or even legal requirements like the EU AI Act. So how do you do all this compliance stuff while still maintaining accuracy of the model? There are trade-offs like the famous bias and fairness trade-off, which we see and still doesn't seem to have a good solution. So this whole responsible AI seemed to be, for the last few years, certainly as long as I've worked in it, all about this work around compliance and ethics, privacy, transparency, bias and fairness, and so on and so forth. And there are assurance technique companies out there that you can use to attest to whether or not you are compliant. But I think there's something more broader. I think the bottom half of that circle, when I talk about operational costs in the environment, I think sustainable AI should refer to including the risk management for the environment with an eye on operational costs. So there are techniques to make models more efficient, parameter efficient fine-tuning, low-rank adaptation, quantization. There's a whole load of stuff you can do, certainly on open source models. And a lot of banks I know are experimenting with small language models, some of them open source. I think that's a good thing. I think some of those compute efficiency techniques are needed. I think they should be prioritized so that we can ensure that the billions of floating point operations that are taken to fulfill a response in ChatGPT is right-sized, because many of those calculations are actually simply redundant. And what do we do about the environment? Well, there are techniques for that. There's green ops, which has quite a long heritage. Maybe we can leverage on certain green ops techniques and embed them within our risk management framework. So that actually, when we talk about sustainable AI, we're talking about right-sizing the AI use case for the risks that we have with an eye on environment and cost all at the same time. And there will be many trade-offs in that, many trade-offs. We're doing some experiments at the moment that are revealing more trade-offs. But we don't have to use generative AI for everything, right? We just don't have to. You know, we should look at what we have to use, how we use Gen AI, for what use case, under what compliance constraints. If it's high stakes, it's high stakes. Maybe we'll sacrifice being environmentally friendly if actually the cost of making a mistake is so great. But for many back office operations, maybe we can relax that requirement. Maybe we can do things like caching. Maybe we can do things like intent recognition, trapping prompts before they go to an LLM and resurfacing something cached. I think there's all sorts of techniques that can be used in and around this that aren't really being explored in too much detail. Has DeepSeek changed sustainable AI trajectory? I actually think it's probably going to worsen things, actually. I mean, as great as it was, the work that DeepSeek did in open source their model, and the fact that they trained it on older NVIDIA chips, et cetera, was great. But actually, the real cost of the environment is all at inference time. It's not training, certainly not anymore. Some of the forecasts I'm seeing about the environmental costs during the lifetime of a model is going to be much, much greater than it was to actually train the model. So actually, this is purely personal view, I actually think the proliferation of DeepSeek, as good as it was to destroy the moats of some companies, maybe for the benefit of everyone else, it's actually not going to resolve the sustainability problem. I'm not aware of any work that was undertaken in their model to do that. They did, although they did produce a distilled model that was smaller than the model they trained on. But yeah, I just think, look, people have asked me this question and say, you know, what impact this will have on the environment. And finally, I'd like to finish off with this. I think data and AI ethics, responsible AI is where I work. And I'm really proud of some of the work that we've done at NatWest. We've recently published our AI and data ethics code of conduct on our external facing website. That was published on Results Day, which was February the 17th this year. So we have a group of principles around data, and on the right we have a group of principles around AI. And I'm sorry, it's not very legible. But what we want to say is we want to demonstrate to our customers that actually we embed these principles in risk management. And what I didn't want to do was publish this as a code of conduct with nothing behind it. But for those things, for everything that's named on here, we have controls in place, we have model validation, we have risk management, we have data science tooling that allows us to identify things like bias and fairness, the extent to which we're resolving it. So I just wanted to call that out there, a bit of shameless self-promotion. Okay, I think I'm just on time, so happy to take any questions.